All right, Unit 5 review video. We start with some implicit derivatives. Only 19 questions on this review video. There's only 18 questions on the test. Uh, so this is just like a good practice test for you, but don't assume that these are the only types of questions. So we got this implicit curve, and we're finding dy dx. When we started this unit, we were still taking derivatives with respect to x. And the derivative of 3x squared was still just 6x. It didn't have dx dt's. We're careful about product rules when we have x's times y's. So I have to use the product rule here. We're going to be careful that we distribute, if this was a minus sign, be careful about distributing a negative. You got the derivative of the first times the second plus the derivative of the second. Now this is when the derivative of y we say is always dy dx times the first. I split it up into that. And then add the derivative of y squared 2y, but it's dy dx now. Don't forget the equals and the derivative of the right side. Now, on your quizzes, you were asked to find the derivative at a specific point, and you could plug in your x and y point early on. But this is asking you to find the equation for dy dx, the expression. So this is where we would, well, I can kind of see I want to divide everything by 2 first. Maybe I'll do that later. We want to isolate the dy dx, subtract the stuff, or like just move the stuff without a dy dx onto the other side. Factor out a dy dx from the remaining terms. If you don't remember this, you need to practice it. Factor out a dy dx, and then we'll divide to solve. And we might have to simplify. In particular, I am going to divide everything by a 2. And I might have to take the opposite of both sides. I might have to do more stuff. Like some of these multiple choice questions, the simplification is the weirdest part. If I divide everything by 2, it's negative 3x minus y over x plus y. It also could be positive 3x plus y over negative x minus y. It's lots of options depending on, multiplying the top and the bottom by anything. See, look, they have negative 3x plus y. Well, they're making the entire fraction negative, so they're putting like the negative out in front. And that's tricky. That's tricky. So they like factor out a negative, and that's how like B is the correct answer. Okay, you can probably double check to make sure it's not anything else, but yeah, B is the correct answer. Okay, so when x is -1, what is dy dx? Well, immediately the first thing I notice is that they didn't give you the y, which is unfortunate because usually for all the quiz questions I gave you the x and the y. Because sometimes for given x's, there's multiple y's. This is not the case, but I'm going to go ahead and just find what the y is when x is -1. So I get y equals, I'm plugging in -1 for x. I get 2y equals 2, so y is 1. So I got this point -1, 1. Okay? Now we want to figure out what dy dx is at that point. I get dy dx equals product rule xy. It's like so simple looking that we don't think like our rules apply. You think it's 1 times dy dx, but no, product rule. Derivative of the first times the second plus the derivative of the second times the first. Derivative of x squared. Boom. Now, you could solve for dy dx if you wanted to. But here's an example of like, if you have a point, plug it in if you wanted to. Think of dy dx as being like things, like variables. So like if you add 1 dy dx to both sides, you'd have 2 dy dx's. I was like thinking 2. So I have 2 dy dx's equal 1 plus -2, that's -1. I'm going to divide by 2, I get -1/2. That's one way to get that. The other way would be to go ahead and isolate the dy dx. Oh, I just lost my entire derivative. Okay, good. Isolate the dy dx solve for dy dx. I'm going to subtract dy dxx. This isn't magic. You don't move stuff. Like you subtract, you add. Factor out. When you factor out dy dx from this, you'd have 1 minus x. And then I could divide, getting me dy dx equals y plus 2x over 1 minus x. If I plugged in negative 1, 1, 1 plus negative 2 over 1 minus negative 1, that's 1 minus, that's 1 plus 1, that's 2. That gives me negative 1 over 2. So, boom. Three. All right, same deal. I wish this was a minus sign in front of this. That way I would like tell you, hey, make sure you distribute that negative when you use the product rule. Like that's the biggest mistake made on these. But we take the derivative. The derivative of x is 1. The derivative of 2xy, product rule, derivative of 2 times y plus derivative of 2x times y plus the derivative of y times 2x. Minus 2y dy dx. Don't forget the equals. Don't forget the derivative of 2. Don't leave that 2. That 2 turns into a 0. Big mistake made with that. Again, you could plug in 1, 1 now, solve for dy dx, or you could just solve for dy dx and then plug in 1, 1. I'm going to subtract 1, subtract 2y. I'm just going to practice solving for this. Factor out the dy dx. Make sure your y's look like y's. Make sure your x's look like x's. Be as neat and orderly as you can be so that you prevent silly mistakes which are frequent with implicit derivatives. Another silly mistake made is like if this was 1, 2, it's like plugging in 2 for x even though it's a y. Just pay attention to details. Fortunately, this is 1, 1, so that's easy. All right, I get negative 3 over 0. Now, that's interesting. This is important if your slope is negative 3 over 0. That is an indication that we have a vertical tangent, right? If you have rise but no run, change in y over change in x. Remember tangent slopes. So vertical tangent, that's good to know. But the derivative is undefined, so non-existent is what I think the answer is. I'm going to make sure I got this correct. Yep. I mean, if I plugged in 1, 1 now, I would have 3 plus 2 dy dx minus 2 dy dx, which is 0 dy dx's. So, yes. Doesn't exist at this point. Vertical tangent. There's a minus sign. Okay. So, we want dy dx at 3, 2. That's the slope of the tangent. Okay. Dy dx at 3, 2. I get 6y dy dx. I got minus 4x equals the derivative of 6 is 0. The derivative of negative 2xy. I'm going to distribute that negative to the 2x. So it's like plus a negative. And then use the product rule. So I get to the derivative of negative 2x times y plus the derivative of y times negative 2x. You can plug in 3, 2 now. You can divide by 2 right now. You can solve for dy dx. That's a 3, that's a 2x. Which is what I'm going to do. Add 2x to both sides. You could subtract this, but like that negative can be in front, so that means you could just like add it. And that'll make it a positive. So I get 3y dy dx plus dy dx x equals negative y plus 2x. Factor out of dy dx. Divide to solve. Plug in 3, 2. This is where it's like, be careful. Y's are 2. Wherever I see a y, I'm going to replace it with a 2. X's are 3. So I get -2 plus 6 over 6 plus 3. So that is 4/9. All right. 5. I got an E. You have these on your quizzes. Definitely go back and redo quiz 1, quiz 51. Derivative of sine x is just cos x. I don't need a dx dt after it. Derivative of e to the y. You can think of that as like an O and I. The derivative of e to the power is e to the power. The derivative of y is dy dx. Chain rule shows up in the first lesson's quiz. Go back to that and make sure you know how to take the derivative of e to the y. Make sure you know how to take the derivative of e to the xy. Make sure you know how to take the derivative of log xy. Stuff like that. Chain rule stuff. It's been a while since we've used the chain rule. We kind of have simple derivatives with our related rates problems. dy dx in terms of x. This problem is cruel. Why? Because you divide by e to the y and you get this. Anybody watching this right now? No? No? Anybody paying attention? Look at this. Look at this. Cos x over e to the y. This is correct. I took the derivative of sine x equals e to the y, and I get cos x equals e to the y dy dx. I solve for dy dx by dividing by e to the y. This is my derivative. What the heck? I don't see that anywhere. Who can find why? Because I didn't make a mistake. It's so funny. It's Friday. Nobody wants to do anything. The answer is cotangent. Why? Nope. Everything's correct. Everything's correct. This is correct. Cos x over e to the y is correct, but the answer is cotangent. I could turn my answer into cotangent. In the original equation, you were told that sine x equals e to the y. If you have e to the y in a derivative, you could replace it with sine x. Woo! Good stuff, guys. Good stuff. Hey, look at that. Log x squared plus y squared. This is a good one that you need to practice. Derivative of y, dy dx. The derivative of log x squared plus y squared. You guys remember what the derivative of log x is? Yeah, 1 over x. Great. For log x squared plus y squared, I would need to O and I it. Log parentheses x squared plus y squared. The derivative of log parentheses is 1 over parentheses. Now, a lot of people mess up with logs. We haven't done the chain rule with logs in a while. We haven't done e's derivative in a while. But remember, whatever starts in the parentheses stays in the parentheses. A lot of times people take this and plug it in there, but no. It's 1 over what starts in the parentheses stays in the parentheses, like Vegas, times this guy. Now, that is the entire thing being multiplied by that. My advice for this question, plug in 1, 0. Plug it in right now. Because if you didn't, you'd have to distribute, and it would be really messy. But if they're asking you for this point, just go ahead and make life easy on yourself. 1/2 times 2. Wait, that's not 1/2. Hold the phone. It's 1, 0, not 1, 1. So this is 1 times 2 plus 0. dy dx is 2. Look how easy it is if you plugged in 1, 0. Just make sure, like 1 over 1 plus 0, 2 plus, this has got to be 0 because y is 0. So I don't have to worry about distributing and simplifying for this question. There might be another question where you would. And it's not nice, it's not pretty, but maybe you'd have to distribute, subtract, factor. Maybe you'd have to simplify from there. In the second lesson, we talked about second derivatives. Implicit second derivatives. Key is to find the first derivative. And to simplify it, I divide it by 2. I keep thinking 2 and then I write 2, but I can divide everything by 2 right here. Subtract x, divide by y, you get negative x over y. To find a second derivative, you take a derivative of your first derivative. Okay? Now, ready? Do you remember the quotient rule? We'd have to do the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. And now this is a problem. It's like I have a derivative, a second derivative that has a first derivative in it. Well, that's okay. I know what the first derivative is equal to. I could take negative x over y and substitute it in there. Or we're trying to find our second derivative at this point, 4, 3. Well, I can find what dy dx is at 4, 3. It's negative 4 thirds. Okay, so when I replace all these numbers, y's get replaced by 3, x's get replaced by 4. You can replace dy dx with the number. So I get negative 3. This would be minus 16 thirds over 9. Great. Awesome. All right, negative 3 is negative 9 thirds. This turns into negative 25 thirds. Dividing by 9 is the same as multiplying by 1/9. Negative 25 thirds times 1/9 is negative 25 27ths. Boom. Next question. All right, moving into our friends and related rates. Cylinder, the radius is increasing. All right. And the height is, oh, shoot. We haven't seen a cylinder like this. The radius, changing. The height, changing. I have to use the product rule for this. dRdt is 2. dHdt is decreasing, so its derivative is negative. Which of these expressions gives us dV/dt in terms of R and H? Whew. Whew. Good question. Let's find out. Okay, since everything's changing, I can't plug anything into this. I have to take the derivative of this. I have to use the product rule. 2 pi r dr dt h plus dH dt times pi r squared. dr dt is 2, so 2 pi r 2h plus dH dt is negative 5 pi r squared. So I got 4 pi rh plus negative 5 pi r squared. 4 pi rh plus negative 5 pi r squared. All right, it's not that bad. You just have to use the product rule. We've tried to not have to use the product rule for all of our questions, but that one, there's no way around it. Oh, it's a good one. This is different. This is a good question, okay? This is a good, hey, how well do you know stuff? I'll tell you this right now. You're not going to have a question like this on the test. You'll have more like, how is the angle changing? But here, you're told that in this situation, d theta dt is increasing at 3 radians per minute. We have a d theta dt. At what rate is x? Why do they say x? I'm going to say y because it's a y. At what rate is y increasing in units per minute when y equals 3. Okay, so I'm trying to find dy dt at the moment when y equals 3. Um, I'm assuming there's a lot of assumptions that need to be made. You have to assume that d is not changing. This is like a ladder problem where like this length stays 5, but it's not really stated here, which is not great. D equals 5. Think of this as the ladder problem. D is constant. You're told how much the angle's changing. You're trying to find dy dt. So since we have dy dt and a constant d, I'm going to use sine. Sine theta equals y over the constant d. We're back to taking derivatives with respect to t. I get cos theta d theta dt equals 1/5 dy dt. Obviously, we know y over 5 is 1/5 y. Now, at the moment when y is 3, x is going to be needed. X squared plus y squared equals d squared. X squared will equal 25 minus not. Oh, it's a 4. Never mind. Yeah, we know that. It's 3, 4, 5. All right, cool. That helps me find the cosine of theta. The cosine of theta is adjacent over hypotenuse. It's x over d. It's 4/5. D theta dt is 3. I'll find dy dt by multiplying by 5. The 5's cancel. I just get 12. Let's hope we see 12. Yep, there's 12. Okay, good question, but different than what you've seen, and that's okay. Radius of a sphere. We got spheres is decreasing. Okay, so that's dr dt. Centimeters per second. It's a rate of change. When the radius is 3, at the instant, not fixed. Okay, don't plug this in until the end. What is the rate of change of the surface area? All right, well, take the derivative of the surface area. I get 8 pi r dr dt. I didn't plug anything in for r. R is not always 3. I got dr dt is 2. I got r is 3. Piece of cake. So 6 times 8 is 48 pi. Oh, sorry. Radius is decreasing. That should be negative. That should be negative. That's negative. Here's a ladder. 40-foot ladder. Ladder slipping down the wall. What is the distance RQ? What is the distance at the instant when Q is moving around the ground 3/4 as fast? Woo! Good question. 3/4 as fast as P is moving down the wall. Woo! All right, I'm going to switch this to X. This is Y. Question is, what is X? At the instant that Q, which I'll represent by dx dt, change in X, Q is moving on the ground 3/4 as fast as P is moving down the wall. Now, sorry, that's not, I'm going to say dy. Now, dy dt should be negative. I'm not sure how that's going to play out, whether I need to put a negative here. Because dx dt is positive, dy dt is negative. So that means that there's got to be a negative thing here. Okay? Okay. Now, the Pythagorean theorem can be used, and it can be simplified with that 40, which is constant. If I take the derivative, I get that. Now, I'm trying to find x. tricky question. I'm wondering if I have to use the Pythagorean theorem. So I'm trying to find x. I'm going to leave x. Okay. I have dx dt is negative 3/4 dy dt. And that equals 0. Okay. Oh, man. You're not going to see this question on the test. I might as well skip it, but I want to figure it out. This is a tough question. It's almost like I could divide by dy dt. Whatever dy dt is, I can divide it out. So I'm going to. Dy dt is gone. Now, here's my problem. I got x and y, and you're not going to have to do this, but I'm going to replace y with what it's equivalent to in terms of x. How do I do that? I'm going to solve the Pythagorean theorem for x, which means x equals, and since we're talking about distances, we're just going to do the positive. Never mind, I have to do that with y's, because I want y's in terms of x's. If you're still watching this video, just stop. You should not do this problem. Just keep fast forwarding until the next problem. Then I'm like, that's a good problem. So x times negative 3/4 plus square root 40 squared minus x squared y. Wait, that's it. Equals 0. Oh man, I'm gonna have to solve this. Oh geez. All right, let's keep going. I gotta finish this. This is next level stuff. I'm going to add 3/4 of an x to both sides. I have square root of 40 squared minus x squared equals positive 3/4 x. I had to make sure that I knew that I had a negative 3/4. I'm going to square both sides, getting me 40 squared minus x squared equals 9/16 x squared. I'm going to add an x squared. That's 16/16 plus 9/16, which is 25/16 x squared. I have 40 squared equals 25/16 x squared. I will square root both sides, giving me 40 equals 5/4 of an x. I will divide by 5. 40 turns into 9. I multiply by 4. No. 40 divided by 5 is 8. 8 times 4 is 32. Yo. No way is this answer just 32. Ready? Yeah. Yeah. Oh! Hey! We did it. Listen, don't do that. That was a great question. I'm proud of myself for doing that question, but you don't have to do that question. Whew! That was fun. I haven't seen a question like that kind of like, hey, I haven't seen this one before in a long time. So that was fun. This is a good question. Good question here. Hey, good question. Press play. All right. Radius of the circle is decreasing at a constant rate of 0.1, so that's dr dt. It's decreasing, so it's negative. In terms of the circumference c, what is the rate of change of the area of the circle? In terms of c. All right. So this is one of those questions that I kind of gave you where you need the area of the circle and a circumference of the circle. If you take the derivative of the area, you get dA dt equals 2 pi r dr dt. 2 pi r is just c. dA dt equals c times negative 0.1. What happened? What is the rate of change of the area? This is it. Yeah. Oh, there it is. Negative 0.1 c. Boom. All right. Good. If the base B of a triangle, this is good. This is a good question. Triangle. We don't know if it's a right triangle, but it's got a base. I'm going to call the base B. dB dt is 3. Oh, shoot. The height is decreasing. dH dt is negative 3. So I'm not loving all these problems so far. Your homework problems for lesson 4, besides the challenge problems, your quiz problems from lesson 3 will better prepare you for the test problems you're going to see in terms of related rates. Letting you know that. I like the implicit derivative questions, though. Those are good practice. Which of the following must be true about the area of the triangle? Always increasing, always decreasing. Area of a triangle is 1/2 base times height, but like the base and the height are changing. So you have to use the product rule here again, which I don't like doing. We tried to prevent it. dA dt equals 1/2 dB dt, h plus dH dt times 1/2 b. dB dt is 3. So I get 3/2 h. dH dt is negative 3. So I have negative 3/2 b. dA dt equals. All right, if h is bigger than b, dA dt is going to be positive, area is increasing. If b is bigger than h, this will be negative, dA dt will be negative, area is decreasing. A is decreasing only when b is bigger than h, just because I have these 3/2 and these 3/2. I mean, you could divide both sides by 3/2, and it's like h minus b. If b is bigger than h, it's negative. Whew. 5 more. The radius of a circle is increasing at a constant rate. This is just like the problem we just did. I don't know where I got these problems from. What is the rate of increase in the area at the instant when the circumference is 20 pi? All right, that's good. You need 2 formulas. The area of a circle that you need to know. The circumference of a circle is 2 pi r. You need to know. At the instant that c is 20 pi, we can find the radius. The radius is 10. Taking the derivative of the area, you get dA dt equals 2 pi r dr dt. dA dt is what we're trying to find. dr dt is 0.2. R is 10. 0.215. 10 divided by 2 is 5. 5 times 2 pi is 10 pi. What did I do? Point 0.2 is 1/5. Gosh. 10 divided by 5 is 2. 2 times 2 pi is 4 pi. It's just not thinking. All right. Radius of a circle is increasing and not zero. All right. You had a question like this. The question you're seeing on your test is more like the question that you had on your quiz, where I said, like, the rate of increase of the area is equivalent to twice the increase of the circumference. So the rate of increase of the radius is twice the increase of the circumference. Here, we're told the rate of increase of the area of the circle is equal to the increase of the circumference. Okay, this is when we got are two formulas at play. We've done this with spheres and stuff. Definitely do the third quiz. Okay. And I would say your homework problems, besides the challenge problems, are the good problems that you need to be prepared for your test. Like even that first problem on the homework when you had X, Y, and Z all changing, and you're given like rates of change of like that's a good problem to do. Heads up. I'm trying to find R here. All right, dA dt equals 2 pi r dr dt. dc dt equals 2 pi dr dt. dc dt is dA dt. So if dc dt is dA dt, 2 pi dr dt equals 2 pi r dr dt. dr dt's are gone. 2 pi's are gone. R's 1. Cool. 4 more. Ladder. It's not an angle though. 25-foot ladder, constant. Sliding down, dy dt is negative. When y is 7, what's dx dt? We've done this enough. We should be ready for this. I think this is a 7, 24, 25. Yeah. You will be given problems that are easier to do without a calculator. So you're not going to be given a 7, 24, 25 triangle. Make sure we understand that's constant. X squared plus y squared equals 25 squared. Taking the derivative of this, 2x dx dt plus 2y dy dt equals 0. 2's are gone. We got 7, negative 3, 24 dx dt. Don't forget the equals 0 because you got to add 21 and then divide by 24. Positive. But, positive 21 over 24 can be simplified. Divide by 3, 7 eighths. You get all freaked out. You see all these 7s and these 24s. But you don't have to worry about it. Oh, look at this. Our first instance of a negative number and a positive number. So you added the correct sign. Double check. Should it be positive? Should dx dt be positive? Is x increasing? If the ladder is sliding down the wall, it must be going this way. Now that's going left, I know, but x is increasing, dx dt is positive. So that's good. When x is 8, the rate at which cubed root of x is increasing is 1 over k times the rate at which x is increasing. What is the value of k? Whoo! Whoo! Okay, well, let's figure out, how's this increasing? One third x to the negative 2/3 is dx dt. Whoa. What? Okay. Derivative of this is 1/3 x to the negative 2/3 times dx dt. That equals 1 over k times dx dt. When x is 8, what is k? Well, it's like the dx dt's actually cancel out here. This is a question you don't have to worry about either. It's a good question, but it's confusing. You end up with this, and you get cubed root of 8 is 2, 2 squared is 4, 4 times 3 is 12. You get 1/12 equals 1 over k. K is 12. You had to have the derivative with dxdt and then equivalent to 1 over k times dxdt. That's confusing. Skip this question too. Yay! Yes, 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 yes. Do this problem. This is a problem that's going to be on your test. Not with these numbers, but you know what I mean. Oh, look, and they gave you that the person's 2 meters from the. Oh, he's 2 meters tall. Dude's 2 meters tall. Streetlight's 8 meters tall. Person's walking on the ground at a constant rate. The shadow is lengthening. Ooh, the shadow is lengthening at 4 meters per second. How fast is the person walking? Great question. What's dxdt? We haven't done it this way yet. Same whole situation with your similar triangles. 2 over w equals 8 over x plus w. If you don't understand how I got that, then you just haven't been in class. And this is the only video that you're watching. Okay? Hey, be quiet on your way out. So go back and watch the video, do the homework. If you're just watching this and you have no idea where this comes from, you need to do some more work, bud. I get 2x plus 2w equals 8w. Shh. 2x equals 6w. X equals 3w. dx dt equals 3 dw dt. dwt is 4/9. So 4/3 is what the answer is. Fun. Last question. That was good. How we going? Oh, this is gross. What is the second derivative of 3/0? Listen, I don't really like this Unit 5 review. I'm not gonna lie to you guys. It's shorter. It's tough to give you test questions. Okay. Yeah, I can't put this on YouTube now. I need like your parents' permission. I'm gonna delete. I'm gonna edit it. It's gonna be fine. It's gonna be fine. Clip it out. Okay. Take the second derivative to take the second derivative. I have to use the quotient rule. This is gonna be gross. Derivative of the top times the bottom minus the derivative of the bottom times the top. Oh, so gross. All over the bottom squared. Fortunately, I have the 0.30. I'm going to need dy dx at 30. So 6 over 3, which is 2. Okay, let's find the second derivative at 30. This is a decent question. It's not a great question. Yo, this is not great. This is not a great video. These are not great questions. Quiz 1, quiz 2, quiz 3, homework for lesson 4. I'm telling you, this is good. This is fun and all, but like these are just random extra practice problems. Quiz 1, quiz 2, quiz 3, for sure. Homework problems, especially that first page where it was like a couple other things. You're gonna have an angle. You're gonna have a conical tank problem. You're gonna have a street lamp problem. You're gonna have a Pythagorean theorem problem. Something might be fixed. Something might not be fixed. Okay. Okay. Uh, Spheres, circles, probably a square somewhere. So I hope we did this for fun, but like we're not stressed out about it. Okay. 2 minus 2. That's nice. So that's 0. Minus 1 plus 2 times 2. 4 minus 0. Over Oh, what am I? Start over. This is like the quintessential example of like plugging in. Sometimes we mess up. Dy dx is 2. That's 2. That's 2. This is 0. That's a big fat 0. I'm not worrying about this. But x is 3 and y is 0. X is 3, y is 0. So I have minus 1 plus 4 times 3 minus 0 over 3 squared, which is 9. 5 times 3 is negative 15. Negative 15 over 9 simplifies to be negative 5 thirds. Ah, what did I do wrong? 4 or 5. Jeez, because I'm not doing math. I'm not doing math, guys. I'm not doing math. Can't do math. This is what happens when you rush. It's 3 times 2, which is 6. 30. Negative 30 over 9. Negative 30 over 9 is negative 10 thirds. That negative, that minus right there. All right, once again, not a great video. Good couple practice problems. A couple really challenging problems that you shouldn't be doing at all. Good practice on implicit derivatives. Good little practice questions here or there. But quiz 1, quiz 2, quiz 3. Homework 4. Street lamp, conical tank, angle, Pythagorean theorem will definitely be on there. Later.